Welcome to our deep dive into the atmosphere, the invisible shield that makes life on Earth possible. It's a delicate shroud of gas, a thin membrane held by gravity, yet it protects us from the harsh radiation of space and allows life to flourish. Today, we'll explore its formation, its layers, and the crucial role it plays in our existence. We'll journey from the ground beneath our feet to the edge of space, uncovering the secrets of this remarkable phenomenon. Get ready to explore the profound influence of the atmosphere, from the air we breathe to the breathtaking auroras that dance in the sky. So, what exactly is this invisible shield we call the atmosphere? Imagine it as a giant blanket of air, a mix of gases that envelops our planet. It's mostly nitrogen, about 78%, and oxygen making up around 21%, that tiny remaining percentage. It's a cocktail of other gases like argon, carbon dioxide, and trace amounts of neon, helium, methane, and more. These trace gases, despite their small quantities, play a significant role in our planet's climate and overall habitability. The atmosphere is essential for life on Earth, but it's more than just a protective layer. It's a dynamic and complex system that shapes our planet's weather, climate, and even the evolution of life itself. The atmosphere is our planet's unsung hero, working tirelessly in the background to make life possible. One of its most crucial roles is protection from harmful solar radiation. The sun, while essential for life, also bombards us with dangerous ultraviolet, UV, radiation. Our atmosphere acts like a giant filter, absorbing most of this harmful radiation before it reaches the surface. This protection is crucial for preventing skin cancer and other damage to living organisms. It also plays a vital role in regulating Earth's temperature. Gases like carbon dioxide act like a blanket, trapping some of the sun's heat and keeping our planet warm enough to support life. This natural process, known as the greenhouse effect, is essential for maintaining Earth's habitable temperature. Beyond these crucial functions, the atmosphere also facilitates weather patterns, distributes heat and moisture around the globe, and even plays a role in communication by allowing radio waves to travel. The story of Earth's atmosphere is a tale of dramatic transformations, spanning billions of years. In the beginning, our planet was a fiery ball of molten rock, and its first atmosphere was likely a thin veil of hydrogen and helium. Volcanic eruptions released vast quantities of gases from Earth's interior, a process known as volcanic outgassing. These eruptions spewed out water vapor, carbon dioxide, nitrogen, and other gases, slowly forming a thicker atmosphere. Around 2.5 billion years ago, tiny organisms called cyanobacteria evolved the remarkable ability to photosynthesize. These microscopic pioneers used sunlight, water, and carbon dioxide to produce energy, releasing oxygen as a byproduct. Over eons, this oxygen accumulated in the atmosphere, transforming it from a toxic haze to the life-sustaining air we breathe today. Think of the atmosphere like a giant layer cake, each layer with its own unique characteristics and properties. The layer closest to Earth's surface, where we live, is the troposphere. This layer is the densest and contains most of the atmosphere's mass. The troposphere is where weather happens, from gentle breezes to raging storms. As we ascend higher, the air thins and we enter the stratosphere. This layer is home to the ozone layer, our planet's protective sunscreen, absorbing most of the sun's harmful ultraviolet radiation. Above the stratosphere lies the mesosphere, a frigid layer where temperatures plummet to their lowest points in the atmosphere. Further up, we reach the thermosphere, a layer characterized by extremely high temperatures. Finally, we reach the exosphere, the outermost layer of the atmosphere, where the air gradually fades into the vacuum of space. Imagine for a moment a world without air, a barren, silent Earth stripped of its protective atmosphere. Without an atmosphere, the skies would turn black, devoid of the familiar blue hue we see every day. Without the atmosphere's protection, the full brunt of the sun's deadly radiation would bombard the surface. Temperatures would swing wildly between extreme heat during the day and frigid cold at night, making life as we know it impossible. Water, essential for all known life, would evaporate into space without an atmosphere to hold it in. The oceans would boil away, leaving behind a parched and lifeless desert. Without an atmosphere, Earth would be a desolate and alien world. A stark reminder of the crucial role this invisible shield plays in making our planet a haven for life. Let's imagine the unimaginable. What if, in an instant, our atmosphere vanished? The consequences would be catastrophic and immediate. The first thing we'd notice is the sudden and eerie silence. Birds would fall from the sky, their wings unable to find purchase in the vacuum. Planes would plummet to the ground, their engines starved of oxygen. Within seconds, the lack of atmospheric pressure would cause the gases dissolved in our blood to come out of solution, forming bubbles that would block blood flow and lead to a gruesome death. The oceans, no longer held down by atmospheric pressure, would begin to boil away. Without the atmosphere's protection, the full force of the sun's radiation would scorch the planet's surface, igniting wildfires that would rage across the globe. The atmosphere, despite being invisible, has always been an integral part of the human experience. Our ancestors observed its effects in the wind, rain, and storms, weaving myths and legends around its power. However, the scientific understanding of the atmosphere as a distinct entity, a layer of gases surrounding Earth, emerged gradually over centuries of observation and experimentation. One of the earliest breakthroughs came in the 17th century with Evangelista Torricelli's invention of the barometer. This ingenious device allowed scientists to measure atmospheric pressure for the first time, providing concrete evidence that air, despite its invisibility, had weight and exerted force. In the 18th century, scientists like Joseph Priestley and Antoine Lavoisier made groundbreaking discoveries about the composition of air, identifying key components like oxygen and nitrogen. The atmosphere is a dynamic and ever-changing system, a constant interplay of forces that creates the weather patterns we experience every day. One of the most familiar atmospheric events is wind, the movement of air from areas of high pressure to areas of low pressure. These pressure differences are created by uneven heating of the Earth's surface, driving global wind patterns and local breezes. Clouds, another common atmospheric event, form when warm, moist air rises and cools, causing water vapor to condense into tiny droplets or ice crystals. These clouds can bring life-giving rain or blanketing snow, depending on the temperature and other atmospheric conditions. Storms, more dramatic atmospheric events, are characterized by strong winds, heavy precipitation, and often thunder and lightning. Hurricanes and typhoons, the most intense types of storms, form over warm ocean waters, drawing energy from the evaporation of seawater. We live at the bottom of a vast ocean of air, an invisible sea of gases pressing down on us. This is atmospheric pressure. Imagine a column of air from the ground to the top of the atmosphere. Its weight is the atmospheric pressure at that point. It shapes our weather and lives. Measured with a barometer in millibars or inches of mercury, high pressure means clear skies, while low pressure brings storms. Pressure decreases with altitude. As we climb, the air becomes thinner and the atmospheric weight decreases. Earth's atmosphere produces extreme weather events, from scorching heat waves to bone-chilling blizzards. The Sahara Desert experiences extreme temperature contrasts, with daytime temperatures soaring above 120 degrees Fahrenheit and nighttime temperatures plummeting below freezing. In the polar regions, temperatures can drop to 100 degrees Fahrenheit below zero. Tornadoes, violently rotating columns of air, pack winds over 300 miles per hour. Hurricanes, massive storms over warm ocean waters, are among the most destructive weather events. The atmosphere, despite its familiarity, is full of mysteries that fascinate us. Let's address some common questions about this invisible shield around our planet. Why is the sky blue? Sunlight is scattered by air molecules, and blue light is scattered more. This scattered blue light is what we see as the blue sky. What causes rainbows? Rainbows form when sunlight is refracted through raindrops. The light separates into colors, creating a rainbow. Why don't we feel the weight of the atmosphere? Our bodies are adapted to it. Thank you for joining us on this journey through the atmosphere. We've explored its layers, its history, and its crucial role in making life on Earth possible. From the air we breathe to the weather that shapes our world, the atmosphere is an essential part of our planet's story. Let's do our part to protect it by reducing our carbon footprint, advocating for sustainable practices, and spreading awareness about the importance of this precious resource. Keep exploring, keep questioning, and never stop marveling at the wonders of the cosmos, right here on our own planet.